Hello, everyone. Thank you for joining. Today we have an amazing presentation coming from Daniel Bruce, and I will let him take it away. Daniel, if you could turn on your video and give a little self-introduction whenever you're ready. Perfect. I can see it.
All right, all good?
Yeah, all good. I hear you loud and clear. I'll be here if you need anything.
Awesome. Hey everyone, I'm Daniel Bruce and I'm the Chief Product Officer here at Levatas. Levatas is an AI company and we really specialize in building enterprise AI solutions. Specifically, what I'm going to be talking to you about today is we really specialize in building integrated computer vision intelligence for drones and robotics solutions. So I'm going to be talking a little bit about what that looks like today. My role here at Levatas is I head up our line of product offerings. My personal background is in software engineering and machine learning, really with a specialty in a field called machine perception. And machine perception really focuses on things like computer vision and natural language processing, which focuses on basically giving machines the ability to sense their environment. So this is things like vision and language processing or hearing. Levatas really focuses on building solutions for kind of a wide range of industries. You can see some of the logos here, representative folks that we've worked with. This broad range of focus really gives us a lot of insight into different types of industry problems. And so we're excited to be here today kind of talking about some of the trends that we're seeing in the space where some of the leaders are starting to think through how to sort of step up and expand their drone and robotics programs. We really have three core areas of focus here. We have teams that focus on doing data science and machine learning model development. This is things like predictive analytics and recommendation engines. We offer computer vision and natural language processing solutions. And then we also have full stack user experience and solution offerings. And so our focus is not just on building models, but also helping organizations figure out how to get these models into production. Models really don't do a whole lot of good sitting on a data scientist's laptop. And so we really focus on sort of the full life cycle of solutions. So today, before I get into some specific use cases and talk a little bit more about what we're seeing in this space, I wanted to talk about some of the drivers that we're seeing for robotics and drone adoption in the first place. There's a lot of exciting momentum in this space, and we've seen some sort of common trends that are driving a lot of that momentum. The first trend that we see is really just the advances in the drone and robotics technology itself. This is obvious, but platforms like Boston Dynamics Spot, DJI's platforms, these are really opening up technology capabilities that have never been there today. Building on that, organizations are running pilot programs. They're starting to see how drone and robotics can be used to really help achieve operational goals. Yes, these are cool toys, these are fun platforms to play with, but really as organizations are starting to see real business value come from those, it's sort of driving this virtuous feedback loop and driving continued adoption. Another trend that we're seeing is just the enablement of remote workers. This is a common trend, especially here in COVID eras. We're seeing a lot of companies look towards ways that they can make remote workers more efficient. And also part of that is just taking humans out of harm's way. So for a lot of use cases, especially in industrial context, inspecting equipment or getting that kind of insight requires actually putting humans in very dangerous environments. And if you're able to replace those dangerous inspections with robotic ones, with a human many miles away or at least from a safety of a safe environment, this is a real driver for that adoption. And then lastly, and this is very near and dear to our heart, companies are seeing drones and robotics as really a way of extending their structured IoT program. So if you think about a drone or a quadrupedal robot as really a moving sensor platform, it really unlocks the ability to capture rich sensor data at a scale that just hasn't been precedented before. So with these tailwinds, it's really no surprise that we're seeing the kind of adoption that we're seeing today. There's a lot of opportunity here and a lot of momentum. That said, it's not as easy as just going and buying a robot. And so what we're seeing on our side is we're seeing a lot of organizations that are relatively new in their sort of adoption curve for drones and robotics. This has been the case over really the last, say, 3 to 5 years. So a lot of organizations are kind of dipping their toe into these technologies and piloting them, trying them out. The first challenge that they run into is just, it's the obvious one, is managing the drone and robotics hardware, getting the hardware, managing the logistics, setting up the environment, training staff, dealing with regulation and safety issues. There's just a lot of sort of first level challenges that are there. That's really been the main challenge that we've seen organizations working through over the last couple of years. But very recently, I'd say really in the last 12 to 18 months, we've seen a bit of a shift in the trend where a lot of organizations have worked through that first layer of challenge. And beyond that, they're bumping into these other two challenges that are exciting challenges to tackle, but also really important ones for organizations to figure out if they want to scale up their approach. And what these look like is really recognizing that true automation is still a future objective for a lot of these use cases. So the goal is replacing humans or replacing pieces of what humans are doing with automation. True automation is still not possible for a lot of contexts. And so organizations are thinking through, how can we still get the value from drones and robotics without being able to completely replace those human tasks? And then the third challenge that we see is organizations recognizing, while the opportunity to leverage this unstructured data is massive, traditional analytics tools don't work very well for things like acoustic data or image data. And so what we focus on is really helping organizations overcome these two challenges using a set of modern technologies, and specifically the technology I'm going to talk about today is computer vision. And computer vision really is a key for organizations kind of unlocking those challenges and sort of taking things to the next level. So first off, before I talk about some specific examples, I want to give just a quick overview of what computer vision is, in case you haven't heard of this before or aren't familiar with the term. So computer vision is a field of AI that really focuses on drawing rich insights out of unstructured image and video data. The ability to not just see things, not just see pixels in a picture, but understand what's going on. That's something that we really take for granted as humans. It's a core part of our intelligence and how our brains work. Computers don't understand how to do that natively. They just see pixels. They see zeros and ones. They don't understand what's actually going on. And so computer vision is really a field which focuses on training AI to be able to do that. There are really three core tasks that computer vision is focused on. The first is object identification and tracking. And so this is really about understanding when there's a car or a person or a piece of equipment in a screen, understanding where it is and then potentially tracking that over multiple frames. A second task that computer vision focuses on is classification of objects. So for example, understanding not just in an industrial context, not just understanding that something is a pipe, but understanding whether or not that pipe is leaking, or if it's in a normal state. And then anomaly detection focuses on understanding change and novelty. So understanding when something looks different than it's expected, something looks different than normal. And this is a really important use case in industrial context, especially because usually anomalies are bad, or at least I could say often anomalies are bad. If you know what normal looks like and you're able to identify something that looks abnormal, a lot of times those are actionable situations. Now, as it relates to applying computer vision to drones and robotics, the connection here is really important. So what computer vision unlocks for drones and robotics is really the ability to take this massive scale of visual data that's being captured and start drawing some real insights out of it. And we see that just the practical industry use cases for this fall into a couple of buckets. So the first bucket is what I would call batch post-processing. So in this use case, a drone or a robot goes out into the world it's got a camera mounted on it or a camera integrated into it, and it captures just a whole bunch of visual data, images or video. That data all gets stored back to a central location. And then we use computer vision to do post-processing of that data. So the capture has already happened, the mission is completed. And basically we're doing post-processing to pull out things like, did we see any pieces of equipment that were faulty? Did we find an analog gauge along the way? And what was the reading on that gauge? Those types of insights are what we're looking for. A second use case that we see very often is actually doing real-time flight or route optimization. And usually in this use case, there's a human operator that's actually controlling the drone or controlling the robot. And so the way that this works is, if you imagine the human operator, they have a controller that they're using to control that robot. On their field of view, what they're seeing is actually a computer vision model that's analyzing what they're seeing and identifying potential places that require further review. So an example of this might be, you may have a drone pilot that's flying over crop fields, and we've got a computer vision model that's running in real time, identifies a potential disease hotspot in the canopy that we're looking at. And the human operator sees a little bit of a indication on their screen of where that hotspot is. That's an indicator to the human that you might want to zoom in, get a closer look, and identify if that's actually a disease or if that does require additional attention. So these two use cases, I'd say these are the majority of places where we're seeing organizations use computer vision today. But the ultimate goal of this is really true flight or mission automation. And that's where you can actually have computer vision running on the device in real time and actually controlling the robot, telling it where to go, telling it when to stop, telling it when to zoom in. I can tell you for most of the organizations we're working with, this is part of their plan, but this is part of their future plan. Regulatory issues and just the evolution of the technology itself means in a lot of cases that the full automation is not quite possible yet, but that's certainly the holy grail of what computer vision can unlock. Okay, so to make this a little bit more concrete, I'm going to talk about just a couple of common computer vision applications, especially integrated applications where we see computer vision being used in tandem with drones and robots. So the first I'm going to talk about is analog gauge reading. So in this use case, what this looks like is a typical industrial facility, think like a nuclear power plant or a manufacturing facility or a coal plant, something like that. These facilities will have tens of thousands and in some cases hundreds of thousands of analog gauges. It's very expensive, in fact, prohibitively expensive to replace them with smart IoT gauges. And so the way that drones and robots can be used is you can actually have a robot that's patrolling that facility or doing automated missions with a camera, capturing these gauges as it does its patrol, and then using computer vision to convert those pictures into digital readings. So for example, understanding that this gauge here is reading 35 PSI, that gauge is reading 20 PSI, storing that all back into a structured environment so that those analog gauges can actually be used as first-class citizens of a IoT strategy. A second common use case that we see come up is thermal anomaly detection. And so in this situation, we're using infrared cameras, again, mounted on either drones or robots. And the goal here is to identify thermal anomalies within a facility. So this might be a piece of equipment that's running too hot. It might be a piece of equipment that's running too cold, but basically identifying where there are heat signatures that are of interest to be inspected. These are things that in some cases humans are doing today. In some cases, it's just not feasible to do that because there's so many different places that need to be spot checked. And then a third use case that we see come up often would be something like after hours facility patrol. So imagine instead of having a security guard or a bunch of security guards monitoring a facility, actually using drones and robots to identify where there is suspicious activity or a person somewhere where they ought not to be. In addition to these, I would just call out, this is a number of different types of use cases that we see come up. These are very common use cases that sort of arise in our world in an industrial inspection context. So everything from fire detection to pipe inspection, mold detection. These are very common industrial use cases. In fact, we actually have a product offering that's really focused around sort of simplifying and expediting these types of inspections. And the next thing I wanted to talk about is I wanted to give some actual real world use cases of where we've seen computer vision and robotics being used in our not just abstract use cases, but specific applications for our customers. So the first one I'm going to talk about here is using Spot, the Boston Dynamics Spot robot, in tandem with a nuclear facility to do automated rounds and readings. And so what this looks like is we've actually mounted a thermal camera and an RGB camera on top of Spot. Spot is doing automated rounds throughout the facility. And as he's walking around, we're looking for things like leaks, pipe leaks. We're doing automated reading of analog gauges. And all of that data is being reported back to a central data lake, which can be used as part of the organizations. In this case, it's a utility company that's using this to create sort of smarter interactions and smarter business decisions. In their case, these patrols were things that were being done by humans. They had expensive human operators that had to walk around the facility doing safety inspections on a regular basis. And they're looking actually at replacing a lot of those rounds with an automated solution like this. A second practical use case that we've worked on very recently is based on doing inventory tracking. So actually looking through a warehouse, looking at boxes, looking at different inventory items that are on shelves, and basically doing an automated inventory count. Again, this is integrated into our customers' basically workflow and inventory management system. And so using Spot, we're able to actually automate the collection of that instead of having more expensive people out in these warehouses doing manual count. So you both get the value of more accurate and more frequent inventory counts, and the fact that it's actually a lot cheaper because you're not having to pay people to do that counting for you. Another type of use case that we see, this is one using drones. So this was for one of the world's biggest utility companies. And they're actually using drones to do automated inspection of electrical equipment. So they're flying drones over top of their electrical grid. And they've got computer vision that's running on these drones that's doing real-time detection of electrical components, classifying out what's a lightning arrestor, what's an insulator, and then ultimately actually identifying when there are fault states for that equipment so that they can proactively repair that equipment rather than waiting for a much more expensive outage to happen, which requires, obviously that's more expensive for them, but it also affects the reliability of the service that they offer to their customers. And then another use case that we've worked on recently is for Royal Caribbean. So we're actually doing automated computer vision analytics to understand basically guest analytics on their ships to identify where people are congregating and where different locations within the ship are potentially getting too busy. So this actually helps our customer here to make more intelligent decisions and more intelligent recommendations to their guests so that the guest experience is really optimized and they're able to make real-time recommendations that maybe you should check out this facility on the ship or go to this restaurant because the wait time at this restaurant is going to be longer than you would like. In this case, this is actually integrated. The computer vision model is actually integrated with their CCTV system. So we're not using drones or robotics. We're just using fixed cameras to do that analysis. Okay, so I hope that gives you a little bit of a flavor of what the space looks like right now. I wanted to leave you with a couple of thoughts just about if you're in the process of kind of evaluating using computer vision to take your drone and robotics game to the next level. I wanted to give you just some practical takeaways of how we would recommend getting started with computer vision. So first of all, we would highly recommend take the time up front to focus on the right use cases. I know this seems obvious, but one of the biggest mistakes that we see for potential customers that we talk with is they tend to get drawn into use cases that are really cool, really sexy, but not necessarily valuable. And so taking the time up front to really think through what is the ROI story, how is this going to drive better results or a better outcome is really important. And so typically what we see in terms of themes for that, we see ROI typically being driven either by augmenting or replacing manual tasks. So replacing things that requires humans today. Or also identifying very expensive anomalies like equipment failures or quality defects in product more quickly. So there may be scenarios where it's actually not practical today to have humans perform inspections. And those tend to be the right type of use cases to get started with. Secondly, we recommend find partners that are compatible with really the best of breed drone and robotics providers. The interface point between the hardware and software is one of the most important components of these types of solutions. And so finding the right partners that understands that ecosystem is really, really crucial. The third thing we would recommend is consider not just the computer vision model and the robotics piece of this, but really the full solution stack. The best solutions live inside of a very robust enterprise ecosystem. And that means you have to think through how the data gets managed, how these insights make it into an enterprise application ecosystem, and really thinking through kind of like the whole glue of how that solution comes together. It's really a critical part of these solutions. And so if you're looking for a partner to support this, finding a partner that's able to really glue all of those pieces together is critical. And then the last thing I would say is that we notice a trend with a lot of our customers who are successful with these computer vision implementations, that often the right solution for them involves taking a very balanced human in the loop approach to this. The best strategy is often to augment humans, not to try to fully replace what humans are doing today. There are pieces of these tasks that humans are just much better at, and they're way too expensive to try to fully automate. And so the real value often comes from finding that balance between let the AI do and computer vision and drones, let them do what they're best at, but keep a smart human in the loop strategy there to let humans do the ambiguous and anomalous tasks that are very hard, sort of the corner cases that are very hard to automate. So that's it for today. Just a quick summary of what we talked about. We talked about a little bit of some of the drivers that are driving the adoption of drone and robotics. We talked through some of the challenges to adopting and more importantly to scaling your drone and robotics program and how CV is really a crucial part of that. We talked through some specific use cases and demonstrated some real world use cases where companies are using CV to drive that type of scale. And then talk through some recommendations for how you can get started with CV if you're looking at that today. I hope that's helpful. I hope that gives you a little bit of a flavor of what we're seeing in the space today. If anything that we talked about here is of interest to you and you have questions, we would love to answer them. Feel free to reach out and we'd love to talk more about that. Thank you.
All right, a big virtual round of applause for Daniel, everyone. Thanks for joining, Daniel. Everyone else, stick around. We've got more content coming now.